In previous modules, we've derived the theory of demand. We've derived how, in principle, you get from preferences and budget constraints to optimal quantities chosen. As a practical matter, we tend to work with this utility function u equals xy a lot in this class. So in this little module, I want to talk literally about how we work with the utility function u equals xy to find answers to problems. This is kind of handy. So, let me start with the punchline and then I'll explain it. When the utility function equals u equals xy, or is u equals xy, then the resulting demand functions showing the optimal quantities of good x and the optimal quantities of good y are going to equal I divided by 2 times px, and for y it's I divided by 2 times py. Right, so that's the punchline. It shouldn't be clear why that's true yet, but let me explain that. So how do we know this, or how do we derive this? Well, we have two things that we know about the optimum. One is that we're on the budget constraint for the optimum, and the other is that at the optimum, minus the slope of the budget constraint equals the MRS. Remember, we've had a few different ways to say that. Sometimes we say, the slope of the indifference curve equals the slope of the budget constraint. Well, since the MRS is minus the slope of the indifference curve, this is the same thing. But again, there are these two conditions. We're on the budget constraint, and minus the slope of the budget constraint equals the MRS. So, how do we use these two conditions? Well, the slope of the budget constraint, an expression for that is just px over py. And an expression for the MRS that we've derived a while ago, and remember that's the expression for the MRS when u equals x times y, is that the MRS equals y over x. So the condition that the slope of the budget constraint equals the slope of the indifference curve can just be rewritten as this. And if we just cross multiply, so if we have y over x equals px over py, that's equivalent to saying py times y equals px times x. Now that, although this isn't yet the answer, even just at this juncture, we get a little bit of interesting intuition. Because what we're saying is with this utility function, at an optimum, the expenditure on x equals the expenditure on y. Well, how do I know that? Look back over here. This equation says py times y, which is the price per unit of y, times the number of units of y purchased, and of course that's just the expenditure on y, equals the analogous thing on x, the expenditure on x. Okay, well, let's hold that thought and we'll come back to it. Now let's restate this condition. We can restate this condition one of two ways. We can either say that x equals py over px times y, or that y equals px over py times x. Why do I say that? Well, think about this condition and imagine dividing both sides by py. Then we'd get that y equals px over py times x, which is just this condition here. Or we could take this condition here and multiply both sides by py over px, and we'd end up with this expression, or this equation right here. All right, so far we've just used the first condition, which intuitively is that the slope of the indifference curve equals the slope of the budget constraint. The second condition, though, that we're on the budget constraint means that this equation has to hold. Our expenditure on x plus our expenditure on y equals our income. So the game plan here is to plug one of these conditions here into the budget constraint and solve for x or y. Let me show you. So putting 1 and 2 together, what we can do is write this expression for the budget constraint, and now let's substitute in for y. So remember what we said on the last slide was that y equals px over py times x. So if we substitute that in for y here, we get this equation right here. Well, now we have a little bit of solving to do, and let me just do that in the blank space here. Px times x is the first, plus py times px over py times x equals I. Well, the py over py just cancel. Now we have pxx plus pxx equals I, or to say that another way, 2 times pxx equals I. What are we trying to do here? We're trying to solve for x, so we can just divide both sides by 2px. We have x equals I over 2px. And since that's the answer, we'll call it x star, and indeed that's what we have right here. One can similarly find, I'll let you do it, but it's the same process, that y star equals I over 2py. So how about a really specific example? So here's a utility function, the one we generally use, u equals x times y. We have a level of income now. The individual has $200 to spend. The price of good x is 4 per unit. Price of good y is 5 per unit. So what are the answers? Well, that is, what is the optimal amount of x chosen? Well, it's I over 2 times px. So in this case, that equals 200 over 2 times 4. And so that equals 200 over 8, or 25. Similarly, y star equals 200 now over 2 times the price of y, which is 5. And that's 20. Now let's see, is this a correct answer? What are some things that ought to be true if it were a correct answer? Well, with this utility function, we should have equal expenditures on the two goods. Expenditure on x is the quantity of x chosen times the price, so it's 25 times 4 equals 100. Expenditure on y is the quantity of y chosen, 20 times the price, which is 5, and that equals 100, so check. And the total expenditure is 200. If you sum up the expenditures on those two, you end up with the amount of income, so we're on the budget constraint, and so bingo, this seems like a correct answer. Even though we already have the correct answer, we could go a little bit farther and ask the question, is the MRS equal to minus the slope of the budget constraint at what we think is the answer? So what's the MRS here? Well, the MRS is y over x, and so that's 20 over 25, which equals 4/5. What's minus the slope of the budget constraint? Well, the slope of the budget constraint here is minus px over py, which is minus 4/5. Minus that is minus minus, or plus 4/5. That equals the MRS, so check again. That is, check. No, you don't have to check again, but we give ourselves a check mark again. This is the correct answer. All right, let me talk a little bit about a more flexible utility function. This is in part because I want you to realize that we work with a simple mathematical function usually, u equals x times y, but we don't think everyone is the same. And if you're concerned that we always write down the same function and you think we're ignoring the heterogeneity of humanity and worry how we would even deal with it, that's what this slide's about. So we could imagine, and we could have a slightly more general utility function where the exponents, instead of being x to the 1, y to the 1, or whatever, we could have x to the a, y to the 1 minus a. Now it turns out that the demand functions that result from that would be the following. X star equals a times I over px, or another way to say it is a equals pxx over I. Well, what does that mean? So this px times x, that's expenditure on x. Expenditure on x is a share of income, is the share of expenditure that's on good x. And what we're saying is, with this utility function, the share of expenditure that's on good x is this thing a. And so, for example, if a particular good were 1% of an individual's expenditure, and let's say that good y is all other goods, then this function, u equals x to the 0.01 times y to the 0.99, that would be a reasonable function for approximating them. All right, what are the takeaways here? Well, first of all, when u equals x times y, the optimal amounts of x and y are I over 2 times px and y equals I over 2 times py. And we get this using two ideas. First, that the slope of the indifference curve equals the slope of the budget constraint. And second, that at the optimum, we're on the budget constraint. The other point here is that If you have a little more general utility function, as follows, then A is the share of expenditure that's on good X, and 1 minus A is the share of expenditure that's on good Y.